Hi everyone, I'm Manami Roy. I'm a graduate student in Raman Research Institute, India. Today I'm going to discuss my recent work with Biman Nath and Mark Boyd on panoramic view of the circumgalactic medium in photoionized precipitation model. In this paper, we extend the work of precipitation limited model by Mark in his 2019 paper and develop a photoionized precipitation model. There are two main players in this game of precipitation limit. One is cooling, another is gravity. The tug of war between the timescale of these two processes gives us this limit. Recent studies support that there is indeed a threshold value of 10 to the ratio of cooling and free-fall timescale at which multiphase condensation becomes possible. For our model, we consider CGM to be in hydrostatic equilibrium in galactic potential well, assuming T cool over TFF to be 10. For developing photoionization model, we use the extra-galactic ultraviolet background radiation at redshift 0. However, this is tricky, as cooling function will depend on both density and temperature, unlike the collision ionization case where it only depends on temperature. As you can see, the difference between cooling function for photoionization and collision ionization is large in the case of lower density gas, particularly for temperature less than 10 to the power 6 Kelvin. Therefore, we use a two-dimensional interpolation scheme in density and temperature to the cooling function to iteratively solve for density and temperature for the photoionized precipitation model. As you can see, the difference between collisional and photoionization model are pretty small for the massive galaxies and are larger for low mass galaxies. We also take into account inhomogeneous CGM by considering log normal temperature distribution around each radii. For Milky Way, we calculate the variation of column density of O7 and O8 with galactic latitude and longitude and compare them with soft X-ray observations. We find that with increasing log normal fluctuation, there is no change in O7 column density, but a range of sigma LNT from 0.6 to 1 is needed to explain O8 column density and ratio between O7 and O8 column density. As expected, there is very little effect of photoionization on these column densities for Milky Way. However, precipitation limited CGM models of lower mass galaxies have considerably lower densities. That means photoionization becomes more important for them. Interestingly, as you can see in the plot, for low mass galaxies with halo mass less than 2 into 10 to the power 11 solar mass, photoionization plays an important role to explain the expected high O6 column densities, where only collisional ionization model failed to explain the same. However, the value of NO6 from photoionization model is not quite as large as the median value of NO6 observed in the dwarf galaxies by Johnson et al. But we know there is uncertainty in the CGM extent. So if we extend the O6 column density integration to 1.2 times of radial radius, the result then agrees with the observations. The largest effect of photoionization is on OVIII ion, which does not produce any measurable absorption in the collisional ionization case because virial temperature of a low mass galaxy is pretty away from the favorable collisional ionization temperature for OVIII. So, photoionization is necessary to produce significant amount of OVIII. Therefore, we propose that for low mass galaxies, OVIII can be a possible diagnostic for the effects of photoionization. That's it. Thank you for your attention. Please feel free to reach out to us if you have any feedback or comment on this work. Thank you.